Hi guys, in today's lesson, we're going to be deriving the various formulas under the circular motion. In our previous lesson, we did a very breathtaking job on and the introduction, to circular motion. So today we're going to be deriving a couple of basic formulas that we're going to be using to solve questions on circular motion. So today we are going to start with the very basic ones that has been said. So today we're just discussing what we call the linear. Don't forget the linear is set as tangential. The linear or tangential and angular, or sometimes we call angular centripetal, linear tangential and angular displacement. This is what we're going to derive driving formula for this very two quantities today. So we're going to look at how we can derive the formula for linear distance of displacement and then angular displacement. So let's see how we go about that. First of all, we're going to be using um, a uniform circular motion. Let's do that. We're going to be using this, and also not only uniform, also horizontal circular motion. That's what we're using. So you have a body being whirled like this at a given angle. Now, at this very point in time, you have a speed at point A, velocity of A. At point B, you have a speed, velocity of B. Now, the fact is this. Now, there's a fact. We are discussing two things. Don't forget the first is angular displacement, and the second is linear or tangential displacement. That's what we are discussing. We are discussing these two major quantities. So now, what's going to be the formula for angular displacement? Now, angular displacement, since you're talking about circular motion, angular displacement doesn't have any major formula. As you can see, the angular displacement you're talking about here is simply theta here. But we are talking about a very small angle, a very tiny angle. We're not talking about a big angle. And that's why this very angle here cannot be in degrees. This angle here will be in radians. Now watch, theta is in rad as radians. Radians is simply an angle in a circle. The angle we have in a circle. Now there's a circle here. There's the center of the circle. Now there's a radius. These are the radiuses or the radii. So the angle we have in a circle is what we call radians. So we also call it rad, R-A-D, in short. So this theta is in radians. Theta is in radians because we have a very small, because we have a very small angle. Now theta is in radians because we have a very, very small angle. Now, what is going to be